Well, good evening, everyone. My name is Michael Smith, and today I will be presenting my project, Prostate Cancer Disparities, Role in the Microenvironment. Now, prostate cancer is a complex disease that affects millions of men globally. Among men in the United States, African Americans and European Americans have a higher incidence of prostate cancer. Between the two groups, there's an increased rate in African American men once they hit the age of 50 and so on. The mortality rate of African American men is much higher than European American men. If you remove the social determinants of health, you still see an increase in prostate cancer mortality. Prostate cancer is a health disparity of African American men, and understanding and taking a biological approach will help understand why this disparity continues. Now, tumor dissemination is a process in which the tumor goes from one part of the body, leaves the primary site, and enters to another part of the body. And in order for it to do that, it has to transport. It has to transport itself to that part of the body. And one way of doing it is through the bloodstream. And so it is going from one microenvironment into another. And in this case, this microenvironment is the circulatory system, circulatory microenvironment. Within that environment, the prostate cancer cells interact with several cells. One major cell that they interact with are platelets. In the literature, platelets have a causal relationship with tumor cells, and it has been shown that through their interaction, there seems to be an increased risk of thrombosis. More importantly, there also, in addition to that, it seems that there may be some type of communication going on between the two cells. However, there is no literature that suggests that in prostate cancer until now. And so my project basically is trying to find out or understand these interactions between the platelets and tumor cells, and trying to determine which ligands, receptors are involved in this communication, which possibly may lead to different hallmarks of cancer. Now, in figure 2A, you see that you see the fluorescence figure that shows the tumor cells interacting with prostate cancer cells, and you also see it with the light micrographs. The light micrographs show that as well. You see the interact, and there's a tentacle-like area that's reaching towards the platelet. You also see that in panel B, figure 2, you see that there's an increase in invasion by introduction of platelets. In figure 1, you see that there's also an increase in calcium activity. At the very bottom, this is a result of the RNA sequencing, which gives us possible candidates for targeting various surface molecules that may be involved with this interaction. And in conclusion, platelet activation releases growth factors, and so understanding these particular growth factors and blocking them, we will be able to come up with ways in which to disrupt this particular interaction, which will lead to better drugs that will help in eliminating prostate cancer. Thank you.